So welcome to our third virtual session for Earth Science. Today is going to be pretty short and sweet. We're going to do some background information on the water cycle, including some extra information that's not provided to you in Canvas. And soon we're going to do a project where I'm actually going to be testing the water quality. Well, really, I'm going to use data from water that we already tested this year from the Columbia River and Tanner Creek. And we're going to describe sort of other things that might be in the water that we didn't test for and sort of what that means. So that's going to be coming next. So in today's virtual session, we will be describing the water cycle, which should be part of a review. You've probably heard about the water cycle many, many times. And we're going to identify properties of water and identify potential human impacts on the water cycle, including something called eutrophication. So, the warm-up question is, what do you already know about the water cycle? Right? I said draw, kind of hard for you to draw if you're in the chat, but regardless, I'll give you guys probably about a minute here to come up with something that you already know about the water cycle and type it in the chat. It could be even the tiniest detail. Thank you, Jack. Respiration, I'm assuming maybe, like from a plant, leads to precipitation. Sure, that's a great two vocab words that are definitely part of the water cycle, right? Respiration and precipitation. You might also have just been thinking in your mind, right? Rain falls, it goes on the ground, it evaporates, it falls, it goes on the ground, it evaporates, right? That's a simple way to think about the water cycle. What does the word cycle mean? Never ending. Great definition, Alina, right? Something that's just going to keep happening over and over and over. We're going to see a ton of cycles in earth science. Pretty much everything is a cycle, right? If in doubt, assume it's a cycle. We have the rock cycle, we have water cycle, we have carbon cycle, nitrogen cycle, etc., right? You can pretty much put anything in front of cycle and it's probably something we will talk about in this class. So you guys probably have kind of an idea of this. So we're going to review water cycle really quickly. Some of these words might be newer to you, right? And some of them we don't really talk about too much, except in really, excuse me, what's the word I'm looking for? Strange situations where you might come across something. So it looks like the word you were meaning here, Jack, was transpiration. Right, something that comes out of a plant, although I knew what you meant. When it's basically when plants release water out of their leaves, right? Usually plants don't want to do that, but if it's really hot, they have no choice because water will start evaporating, right? So the general concept here is water is in a cycle. Big surprise, right? There's precipitation, which could be in the form of snow, rain, ice, a combination of those things. Some water actually even comes out of volcanoes. Right? In fact, you even breathe water out of your mouth every time that you breathe or talk. So water vapor is everywhere, right? It's coming from a bunch of different places. We can see that water vapor when we have fog or dew. We also We'll see evaporation coming from oceans, lakes, rivers, the ground, right, if there's a ton of water on it. Transpiration is when that is happening from a plant. We also see infiltration of water, which is a weird term, but really it just means water's going into the ground. Right, that's actually an important part of the cycle. Does anyone want to take a guess as to why that is? Why might it be important for the water to actually go in the ground, filter through the ground? It's kind of a hard question. You might be thinking in your mind, so that plants can get water? To some extent, yeah, but the ground can actually help filter water, right? So the ground can help clean water. As water goes through layers of rock, sand, dirt, etc., right, it will actually get filtered and will get cleaner than it was when it landed on the surface of the ground. So that can be an important natural filtering process. You've probably used a water filter to purify water in your fridge or something like that, right? It's the same concept, but the ground does that naturally. Also, some water is stored underground. Yeah, so it's kind of like the water goes into the ground and then we get cleaner water. Exactly. Right. And that's not always the case because, of course, there can be pollution in the ground too. Right. There could be oil there. There could be something that gets in the water, which would be bad. But it does filter and clean. So, another interesting point here that is something that people always seem to forget about is this surface runoff, which is that water on the ground, some will go in the ground, and the rest of it will go towards a river, a lake, an ocean, any type of body of water that it can get to. Surface runoff is a huge issue because it carries pollution to new places, right? So imagine you have a farm with a bunch of cows. Cows poop a lot. You're going to have a ton of cow manure all over your farm. You're not going to be cleaning up cow manure at every moment of the day, right? It would be impossible. They poop like ridiculously. So every time it rains and your water starts draining off to another location, water will take contamination from that poop to another place. So that could be going into a river, right? That could be going into the ground. That could be going into your well water for your house, if you have well water. That could be going into an ocean, right? So surface runoff can actually be a huge component of pollution just because humans, of course, and animals have waste. So we're going to come back to that. The other thing I wanted to emphasize here, yeah, spreading diseases, exactly, right? You guys have heard of all those E. coli outbreaks. Remember when you couldn't eat lettuce for a while, right? I don't know. I remember last year we talked about that in biology and people were like, oh, I'm not supposed to be eating lettuce. Romaine lettuce was contaminated, right? And it's because of surface runoff. E. coli was in most likely some kind of animal waste farm, and the water actually brought that E. coli to another farm where there was lettuce and contaminated the lettuce, and then people started getting sick. Yeah, so you had to throw away your romaine lettuce. Yeah, so that happens occasionally where there will be mass contamination. I believe it was like the entire state of Arizona was contaminated, right? It was ridiculous. So it's a real thing that does cause health problems, and not only disease, but we'll talk about another example of that too, something it can cause. So prefixes of water, when you're going through this lesson in Canvas, this relates to lesson 1.01. You will see a lot of these prefixes, and you might see them later in your life, right? Hydro. If you see something in front of a word that says hydro, it's most likely relating to water, right? Hydrosphere. What is the hydrosphere? It's all the water on Earth. Thank you, Jack. Right? It's all water. It's like the sphere of water, right? So the oceans, the ice caps, the rivers, every part of water. Notice it has hydro and sphere. You can think of the Earth's water supply, essentially. Hydropower. What's hydropower? Even if you're not, oh, okay, I was going to say, even if you're not sure, you can maybe think about a guess here. Something it's power, water power, right? It's energy from water. So that would be, for example, a dam, right? Like the Bonneville Dam. Water pours through that thing and generates energy, right? So that can be a great use of water for us. And then the hydraulic cycle is another way that you might see the water cycle discussed. Osmo is also a prefix. We don't see it so much in this class, but osmosis, you may remember that term from biology or from that movie Osmosis Jones, right? But osmosis is the movement of water in and out of cells. And then we also have something like osmotic pressure, which is pressure that water creates, right? So that is used, for example, when you turn on water in your house, right? A pressure system brings the water out of your faucet. There's not water above your house coming down, right? It's being pulled up from the ground. So in that case, water creates its own sort of vacuum to pull water in. Well, we're glad to have you, Alina. You just missed us talking about water a lot. In fact, this virtual session should make you have to use the bathroom because we talk about water so much. I'm not even kidding. Okay, so properties of water and structure of water. This may be new information to you, and if it is, I recommend that you take notes, even if it's just writing down one sentence that kind of summarizes the structure of water. I love it. You're drinking water right now. Perfect. Right? If anything, it will remind you to drink water too. So water has pretty special properties. If you think about it, it's a lot different than any other liquid that you know, right? What other pure liquids do you guys know about? Pure meaning it's like an element from the periodic table or combined of a couple elements. It's kind of a hard question because if you think about most of the drinks that we know about, most of them contain water, right? Soda is water with carbon dioxide dissolved in it and like sugar and flavoring, right? Oxygen wouldn't be found liquid, right? Usually you could make it cold enough to make it a liquid, but it would be really, really, really cold. You wouldn't be alive. Alcohol is a pretty pure liquid substance, right? That's not mixed with a bunch of different things. Mineral water would be a type of water, right? So alcohol is probably like the best comparison here because they're both liquids. They look the same, right? They're both clear. In this case, though, water has way cooler properties than alcohol, right? Some of those properties you might have seen, like for example, when you fill up a glass all the way to the top, water will bubble over the surface, right, before it breaks and spills. You may even be able to walk with that glass and see the water holding itself together, right? So water is attracted to itself. A lot of self-love in the water. This happens because of the way water is bound together. We have an oxygen molecule and we have two hydrogen molecules. Well, oxygen is kind of a jerk and actually pulls more electrons towards itself so that the oxygen actually creates a slight negative charge. At the same time, the hydrogens end up getting a positive charge. What happens then is that water is attracted to itself and it would love to be near itself, right? That's not always the case for other compounds. So in this case, you might see that as water pools together, right? Like if you ever spill something, there's not usually water droplets all over the place, right? Water usually comes together in one big puddle or maybe a few smaller ones. You might even see in a straw, water kind of creeps up the edges on the side of the straw. It climbs by itself. Rain on the car will pool into puddles, right? So these are things that you probably see all the time that you're just like, yeah, water does that. Well, water does that because of its structure. So the structure is incredibly important. It's also known as a polar molecule because of those two charges, right? It has a positive and negative side to it. And water molecules are held together by hydrogen bonds. And hydrogen bonds are the weakest bonds. Well, at least the weakest main kind of bond. And what that means is that water molecules can be broken apart pretty easily, right? But because of those charges, they are attracted to each other. Water is also known as a universal solvent. What do you think that means, to be a universal solvent? It has many tasks. It's a good guess. So solvent means that things can dissolve in water. So when I asked you guys what other pretty pure compounds you know about that are liquids, and I said most of them involve water, guess why? Because water is the universal solvent. Sugar dissolves in water, salts dissolve in water, right? Even oil to some extent will break up, and if you shake it enough, dissolve in water, right? Most things will dissolve in water. Rocks will, carbon will, nitrogen will, all sorts of compounds. Even oxygen will dissolve in water, right? When we do water quality, we look at that. We look at how much oxygen is in the water. So water is great because it will dissolve all these things, but that can also be a problem. Because if water is able to dissolve all these compounds, right, it's going to also dissolve some bad stuff as well as some good stuff. So that's what we're going to kind of get into now, is talking about humans and our impact on the water cycle. But first, changes of matter, right? What does water need to change its state? And remember, states of matter just means solid, liquid, gas. So what do we have to do to water to change its state? Add something that will make it a solid. Well, what will make it a solid? Let's say I have a cup of water and I want it to become a solid. What would I do? We can boil it to make it a gas, or, thank you, John, we could freeze, right? If I want to make solid water, I freeze it. If I want to make gas out of water, I would boil it, right? That might seem obvious, but the real best answer to this question then is, what does water need? It needs a change in temperature, right? If we raise the temperature or lower the temperature, we could see water becoming a solid, a gas, or a liquid. Right now, we usually think of it from a liquid state because most water that we interact with is in liquid form, right? Room temperature, it's liquid. Even pretty hot, right? If you're taking a hot bath or you go in a hot spring, it's still liquid. In fact, water can definitely burn you when it's liquid. Many of you might have experienced that, right? So really, we want to think about that relationship between temperature and water. The temperature is what causes the water cycle to happen. When the temperature changes, water changes state, which then allows it to cycle through different parts of the earth. This is also kind of a tricky question, which is why I'm going over it, because I think they might ask this on the water cycle quiz that you may have already taken, but you should be taking soon. Is matter conserved in the water cycle? You would say yes. Well, yes would be a good guess, and yes is correct, right? The true, real science answer is matter is always conserved. Sometimes it's hard to see that though, but in theory, if you start out with a certain amount of water, right, you are going to end up getting that much of a gas or that much of a solid. Now, it might be a different density, it might be less accessible, but matter is conserved. So then, what does that mean when you hear things in the news, when people say things like, we're running out of water, we're running out of fresh water? Well, are we really actually running out of fresh water? And if we are, how does that make sense if matter is always conserved, meaning there's always the same amount of water available? Because I know you guys have seen some headlines like that where it's like, world will be short of water by this date. Okay, let's see. No, but there's places that could run out maybe of clean and drinkable water. Good, right? So maybe running out of access to the clean water, matter cannot be created or destroyed. Good. No, it might just be getting polluted. Yeah, right? So when people say that, they don't actually mean that water is physically leaving and not able to be used, right? It just means that maybe it's in ice. Maybe it's polluted. Maybe that area of the world no longer has as much fresh water. That fresh water is now elsewhere, right? So that's what's kind of hard about it, is it's not easy for us to just say, well, there should be a river here. Let's just put some water, right? It doesn't really work that way. So keep that in mind. Matter is always conserved, right? As John said, matter cannot be created or destroyed, right? It can only be changed. So how do humans impact the water cycle? Well, I'm sure if I just left that as an open-ended question, you guys could come up with 17 different answers, right? Humans are always messing stuff up. We know that, right? No one's surprised by that. However, type a 1 in the chat if you've ever heard of eutrophication. Type a 2 in the chat if you're like, I have no idea what that is, but I can read the definition. Got some 2s. Yeah, right? This is not a really common word. In fact, I doubt you've ever heard anyone in casual conversation say, what about that eutrophication? But it is a process that does happen, and it involves surface runoff. Like I was emphasizing in the beginning of the lesson, is a big deal, right? Surface runoff is what causes a lot of these pollution issues. So we're gonna watch, we're gonna watch this little tiny video, short video, I should say, not that tiny, about what eutrophication is, and it has just like cheesy music. I don't think they talk in it. This will give you a nice visual of what's happening, right? So there is a tractor releasing fertilizer, right, onto a farm. It's raining. I'll narrate the video since they're not going to narrate it for you, but that's, you know, fun times. Water absorbs into the ground with the fertilizer and actually carries the fertilizer with it, right? Fertilizer will dissolve because it's a universal solvent. Guess what? All that water and fertilizer goes into a lake. Plants absolutely love fertilizer, right? That's why we use it. You use fertilizer to make plants grow. Well, if we give algae in a lake or an ocean fertilizer, it grows out of control, which at first you might think, well, it just looks gross. Well, that's part of it. But what actually ends up happening is a lot of that algae dies because it doesn't have enough nutrients and it's not getting enough sunlight because there's so much of it. Right when the algae dies, it starts putting a ton of dead material into the lake. And look at that little fish. What's going to happen to him, do you think? He dies, right? It actually lowers the amount of oxygen available for fish, and fish die. So not only does algae look gross, but it actually can kill fish, right, by just overgrowing. So type a 1 in the chat if you've ever been hiking or looking around your neighborhood and you look somewhere and you see a lake or a river or a pond and it just has like a ton of algae in it. Like you would not go in it. You're like, right? That's how fish feel too, because it literally suffocates them. That fish suffocated. The dead algae consumed all of the oxygen because the bacteria breaking it down need oxygen to break down the dead algae. And as a result, the fish die. Right? So this is something that only started existing once humans got involved, obviously, right? Because we started bringing fertilizer in to the world so that we could make plants grow where we want them to grow, in a farm, in your yard, right? And then as a result, this surface runoff actually takes that fertilizer, puts it in lakes, and destroys ecosystems, right? So next time you see some algae, you'll be like, whoa, eutrophication is happening over there. And you can throw that out as a nice, fun word to your friends and family, and I'm sure they'll be like, okay. So the other thing is urbanization. What does urbanization mean? Well, it does cause increased surface runoff, but what if I say humans have urbanized Portland? What does that mean? Yeah, to urbanize a place. Yeah, and what does it mean to become urban? Current, that's a good guess. Really, it means to build a city. Yeah, creating roads and stuff. Yeah, it's hard to explain, right? You're like, well, I could tell you in a picture if it was urban or not. Really, it means, yeah, parking lots, roads, buildings, right? Apartments, any other kind of building. Usually it just means getting rid of nature in some way. So we do this as humans, right? Because we like to live in comfort. When we build more stuff, we take away plants, we increase our surface runoff, right? Why does that happen? Because concrete, for the most part, is not porous. That means water can't go through concrete. It can only sit on top of concrete. So then the water is forced to go somewhere else, which a lot of times can cause flooding, right? So I grew up in Houston, which is notorious for its ability to flood in 3 seconds, right? I'm telling you, even before all of these crazy Hurricane Harvey, Memorial Day flood stuff, I had moved away at that point, obviously. But even before all that stuff, I remember when I was in high school, when I would go to the movies, it would rain while I was in the movies, and you would come out in the parking lot, and the parking lot would have 2 feet of water in it. Just from a regular rainstorm. Because there was nowhere for that water to go, so it just pools on the parking lot, right? In extreme situations, if you're getting a ton of rain, that could obviously cause that water to run off into a river. The river could overflow, right? But really, that's a big issue for us. I know people think floods are not that scary, right? But water can kill people. Even if you know how to swim, it can still kill you. So, and it can also carry disease, something that Gio mentioned earlier. So the other problem is that we end up destroying wetlands, right, and natural habitats. So wetlands are usually right along the coast. So if you've ever been to the coast and you see the sand dunes, and sometimes there's like, you know, some watery, wet, swampy looking stuff, that's a wetland. And when we take away wetlands and natural habitats, then we don't have filtration through the soil. And of course, I mentioned this before, right? The full circle right now, when water soaks through soil, it gets cleaned. Well, if we're taking away natural stuff, it can't do that anymore, right? So not only is water going to pool and cause flooding, it's going to be dirty because it's not getting cleaned, right? At the same time, dams and hydroelectric power plants, right, which we think, oh, they're providing power. It's renewable, clean energy, right? It's not oil or gas. Well, sometimes they can cause salmon to not be able to migrate, and they can kill marine life. The Bonneville Dam, if you ever get a chance to go, you should go. It's really cool. They actually have a fish ladder there, which is like basically these levels, and the fish can swim up these levels so that they can get through the dam. And they have windows so you can sit there and watch them. And it's cool. The fish are just like chilling, like totally fine and normal, and they can swim past the dam and not be affected, right? Not all dams do that, right? Most of them at this point do, but not everybody thinks about the salmon, right? But it's cool because we should think about them. The other thing is pollution, right? Which I think is one of the most common things. If I had said to you guys, how do humans impact water, right? You would have been like pollution. Well, pollution is really vague, right? It could be tons of different things. But in this case, when water does run off into a lake, a river, whatever, for the most part, it ends up in the ocean. And down here in the right-hand corner, you can see a picture, right, of some sand up close. And what do you notice in this picture? What is that like orange and blue stuff? Does that look like some naturally occurring sand? No, right? That's garbage. Garbage gets carried into the sand. If you go to the beach and you take a sample of sand, I guarantee you will find some garbage. Right? It's sad. It also ends up in the ocean, right? So garbage is a huge factor, as well as other types of pollution like fertilizer, pet waste. Pet waste is a big one, right? That's why not only should people clean up after their dog because it's gross, but also that surface runoff carries diseases. And if somebody has a diseased dog, right, well, everybody else has that. Yeah, save the turtles. It's true, right? So turtles, of course, get impacted. They end up eating all those little tiny pieces of plastic. If you've ever eaten fish in your life, you definitely have plastic in your body right now that will never go away. Right? So fish also have that. They eat the plastic because it's in the water and it's in the sand, and it is broken up into small pieces. So it's not necessarily like a giant plastic thing floating, right? But they eat it because it's there and they don't know, right? And they can't avoid it. I mean, they're fish. Yeah, it's intense, right? And you probably have plastic in your body even if you haven't eaten fish. So sorry, but you do. So regardless, right, pollution is a vague term, but in this case, it can mean literal trash, or it can also be chemicals. We'll learn when we do the water quality project that also other things are ending up in our water, like people's pharmaceutical medicines. Antidepressants are ending up in water, right? Other kinds of medicine, pain medicine, anything that people take over the counter, it's being released in their urine, right? It's not getting filtered out. How do you filter out these tiny molecules? We don't know, right? No one's doing that. So that's impacting fish, right? Fish are not supposed to be taking antidepressants. It actually will make their behavior change. So we will talk a little bit more about that in the future, right? But pollution can be more than just trash. Keep that in mind, although the trash is also really sad. So the final thing is, well, how can we fix this, right? Because I don't want this class to just be like, boo-hoo, everyone's killing the earth, it's sad. Because it is, but Portland and surrounding areas, right, Gresham even does some of this stuff as well, has some very special stuff happening. For example, there is this special concrete in Portland, in some places, that's called pervious pavement. It is a porous pavement. Basically what happens is it is spacious enough that water can sink down through it. So really it reduces stormwater runoff flow, recharges groundwater, and maintains stream-based flows, right? The cost is that it's $100 per square yard. That doesn't sound that expensive, but I believe that is more expensive than cheap regular concrete. So if you're trying to be cheap and on a budget, you're probably not going to be using this. There can't be a huge slope in the area, right? You have to get permits, etc. But this concrete does exist in Portland, and this is kind of what it looks like up close. It has all these holes in it, and that allows the water to sink down back into the ground, helping the water get filtered. So that's pretty cool. That is not happening in every city. Another thing that we can do is reduce our fertilizer use. Oh, you have it in your driveway, John. That's awesome. Yeah, definitely. So if you ever do anything with concrete where you get to have a choice make the choice to get the porous concrete, right? It's going to be better for the earth. The other thing is you can reduce surface runoff and flooding by just planting stuff. So type a 1 in the chat if you've ever seen one of these weird curvy things on the corner, or these giant sunken in like plant things. I don't even know what to call them. Plant life, right? Again, this is not happening in a lot of cities. In Houston, they have like no plants. That's part of why they get so much flooding. Yeah, an unbushy bush. Yeah, exactly. It's like a weird, whatever, grassy looking thing. So those are actually there to help reduce surface runoff, right? Not only do they look nice, some of them, but they actually help. So you can see here that there's this grate. Water will flow down and go into these plants and let the plants absorb some of that water, and then let some of the water filter down into the ground. So those actually have a purpose other than looking nice, which I don't know if everyone knew that. Some of them even have signs where they like explain that, right? But I know most of you guys are not stopping on the street to read environmentally friendly plant signs. That's just me. I should take a picture of one actually. But anyways, so those are a few things that we can do, right? It's really just planning. It's thinking, well, if we're taking away nature and that's a problem, how can we put nature back, right? If we're putting concrete that won't let water go through it, how can we do that? Oh, well, we can create a special concrete. Fertilizer. Do we need to fertilize everything to the extent that we do? Probably not. Just stuff to think about. And that is the end of this virtual session. There's just a couple things here. In this lesson, 1.01, there is this cloud lab mentioned at the end. And I think I've already had one email this year, but last year I got a lot of frantic emails because it requires a bunch of supplies. You do not have to do that. That is not required. There's no grade for that, right? But if you want to do it, you certainly can. It might help you understand the water cycle a little bit better, especially if you're feeling like this is a hard thing for you to understand. So when you see Cloud Lab, do not freak out. You do not need to do it. Other thing is there is an exit slip for this virtual session. This is going to be the code word. I'm typing it in the chat right now. Got some inspiration from Benjamin's answer there. The code word in the chat will get you full credit on this exit slip. People who did not attend the virtual session will not be able to get full credit. But in the exit slip, which I just published right before this because I didn't want people doing it before the virtual session, you'd be surprised. It says virtual session, and then people do it before the virtual session happens. Anyway, you're going to be answering these two questions, which we went over in this session. What is eutrophication, and how does it negatively impact ecosystems? Yes, Alina, you totally do that. You're right, because you like to go ahead. And is matter conserved in the water cycle? Explain. I will be posting this video probably this afternoon, if not by tomorrow morning. And also this PowerPoint that I just used is posted with this exit slip in Canvas. So you can go back through, you could rewatch the eutrophication video if you need to. You could look at that definition again if you already forgot what it was, because I know it's a big word. Put the code word in your answer, right? It could just be at the end, whatever, so that I know you were present and actually present, paying attention and listening to me and reading the chat and seeing what the code word was. Otherwise, does anybody have any questions about the class, about what you're going to be doing now for the exit slip? Can you use it later, like on the final? So this code word is not going to be worth bonus points. Some of the other ones will be. This code word is actually just going to get you full credit on this exit slip. That's a great question. The first one, the first virtual session that we did where we did have a code word was for extra credit. The lab, which lab are you talking about, Benjamin? Oh, the one that I was just talking about. Well, I'm not going to do the lab, right? If you want to do it, it's going to be up to you to do it at home, or we can arrange a time for you to come into the school if you need to use equipment there. But but it is actually in this 1.01 lesson. So when you go through that lesson, you'll see it at the end. Our first lab, we're not going to do any labs on campus, right? Teachers are only on campus one day this year, so I'm only there on Tuesdays. So water quality testing, we will look at data and analyze data, but we're not going to do any labs together. There are some labs in the course, right? Like the cloud lab, except there's like required ones that are better. So we're not going to do any labs together, so you don't have to worry about planning for that. Any other questions? Okay, I'll take that as a no. Well, thank you for being here today, guys. Don't forget your code word. Write it down. Do your exit slip right now. Just get it out of the way. It's going to be a really easy assignment if you were paying attention. And otherwise, I will see you guys next week.